And I'm Jeremy Kahn from Bloomberg. I cover technology here in London for us. I've got with me Helen Mayhew, who is the Chief Operating Officer for Europe for QuantumBlack, which is, those who don't know, a company that's owned by McKinsey & Company, the strategic consultants, and they help businesses use big data and advanced analytics and AI. I've got Scott Penberthy, who's the Director of Applied AI at Google, which is a company I'm sure you all know. And I have Nigel Toon, who's the co-founder and CEO of Graphcore, which is a company based in Bristol here in the UK that is building specialized computer chips designed to help run artificial intelligence applications more efficiently. And we'll talk a little bit about why that's a necessary thing. But first off, I want to start with a really broad question. What are we really talking about when we're talking about artificial intelligence? Because a lot of people use this term, it gets thrown around a lot. And a lot of people don't have a clear sense of what we're really talking about. So Helen, what are we talking about here?
Yeah, it's a great question because it obviously has become a buzzword. And when we're talking about artificial intelligence, what we're really meaning is a technology that can exhibit some kind of cognitive function that we would typically associate with being human. So that may be visual recognition, that may be some kind of perception, or oftentimes at the moment it is the function of learning, and that is where the idea of machine learning comes from. So hopefully that starts us off by demystifying a little.
Right. Does everyone else agree with that sort of definition? Does that sound good, Scott and Nigel?
I think that's right on point, and what exhibits intelligence. And I think learning is one piece of it. And I think today, in the last few years, the piece of AI is getting a lot of attention, is where you have systems that learn directly from data and experience, and that's the machine learning. And inside machine learning, there's a new area that you're doing a lot of chips around, is the deep learning, what used to be called neural networks many, many years ago.
Yeah, I kind of have a perspective on it that for 75 years, we've been telling computers what to do step by step in a program, and now suddenly we're actually able to learn from data. And what's stunning is that some of what we've been able to do is producing results that are more accurate than we can describe in an algorithm, just learned from data. And actually, we're getting to the point where even some of these machine learning systems are more accurate than a human could be on some narrow tasks.
Right. I think we have a slide, actually. I don't know if they can put up on, this is taken from the AI Index on the performance of ImageNet, on ImageNet, which is this test set of can an algorithm recognize a lot of different images. And you can see that we had algorithms that kind of beat human performance starting in 2015. And what's really interesting, that it looks like progress has kind of leveled off, but there's another slide AI Index did, which is how quickly those systems can be trained. And I don't know if they can get that up there. It's like technical difficulty. But anyway, it's gone down from about 60, it took about an hour in the summer of 2017. It went in about 18 months down to 4 minutes to train a system capable of doing performing as well, and this is above human level on ImageNet. So the progress is definitely being made pretty quickly. I want to get one of our first audience kind of polling questions out there, which is, given this kind of rate of progress, how long do you all think it's going to be before we reach get an algorithm that can achieve kind of human-like performance, human abilities across a range of tasks? So this is something a little bit closer to what they call artificial general intelligence. That can perform a lot of different things. 5 years, 15 years, 25 years, 50 years, or never. And I think I'll throw it out while they're polling to our panelists. Nigel, how long is it going to be till we get to something that is a bit more human-like in its flexibility, in its ability to learn from a little bit of data as opposed to millions of examples?
Well, I think we're making incredibly rapid progress towards systems like that. I think really the question is how broad do you go? I think in terms of replicating a human, this anthropomizing, all this intelligence, I think is slightly dangerous. I almost don't like the word artificial intelligence. I think we should call it machine intelligence because it's going to be a different form of intelligence. But the quote I like is the Wright brothers. The week before they flew at Kitty Hawk, they said it'll be another 5 years before anybody has a powered flight. And then the next week they did it. So this stuff goes in leaps sometimes.
Okay. Well, it looks like our audience is interestingly split, with 25% of you thinking at 15 years and almost an equal number saying never. Scott, what's your call on this?
Yeah, what I like about this audience is that's very similar to what Max Tegmark did with the world's best leaders in AI from London, from around the world. And their results were mainly between in the 15 through 50 years.
Right.
But you had across the board, will we ever have that?
Where do you come, what's your number?
Mine, I think definitely within my lifetime. And I think what we're seeing is the change. We all talk about the exponential change. There's exponential change in students going into the space. There's 8,000 papers that NeurIPS just submitted a couple weeks ago, brought the server down. And so it's changing so fast, but it's also discontinuous. We didn't think AlphaGo would work for a number of years, and boom, we suddenly solved something we thought was even at Google, in DeepMind, 20 years away. And so it's exponential, but there are discontinuous changes, and so I think we're going to see this in our lifetime. It's a fantastic tool.
What's your call on this?
Yeah, I mean, I'm a little bit in Nigel's camp, which is that I think the intelligence ultimately will be quite different. And I think we need to think about machine intelligence and human intelligence differently and really get to grips with what does it mean to bring those two things together. And actually, when we look at most businesses at the moment, even the ability to absorb the current level of capability is quite challenged. And so I think that's the biggest challenge for us. It is less about building the general intelligence and more about bringing the two different types of intelligence to bear.
Right.
Yeah. I think the other thing, just as a reference to this graph, is that scientists always say anything beyond 5 years basically means we don't know.
Right. Well, as we saw from the ImageNet slide we had up before, progress is being made pretty rapidly, at least on the training times. Advances are happening. And it's all being done with kind of current generation hardware. So Nigel, maybe you could explain very quickly, why do we need specialized AI hardware?
Processes always follow the data. And as you look at machine learning problems, the data that you're trying to operate on and work with is very, very different in terms of its structure. You're fundamentally trying to learn from data to capture the salient features from that data. And so there will be, a feature here, there'll be a feature there that's important. I need to bring that together to do some compute and write the answer back somewhere else. And so in computing terms, it's what we call sparse data processing, which is very, very different. So access to memory becomes a big driving force. That needs to be incredibly efficient. Processors today spend most of their energy on actually accessing the data and very little on the actual compute you do, and you need to completely reverse that. And if you could do that through some really clever architectural innovations, which is what we're trying to do in Graphcore, you can see the potential for 2 orders of magnitude improvement in efficiency. So a data center that would be burning, a megawatt comes down to maybe a few kilowatts in terms of power for the same problem.
Wow.
Maybe just one simple observation to that. If you look at what we're thinking of at Google, how many watts does it take? All right, and you see a lot of press recently about the carbon footprint of a deep learning model. It's very high. And so if you look at that, like the human brain, 25 watts.
Yeah.
And it does so much more than these deep learning models. And so we've got this discontinuous change where you've got so much power today, and the human brain, we know it works. So that just sort of tells us we're doing it wrong. So what's the new architecture that's going to give us that kind of improvement in terms of watt consumption for these inferences? And I think you're right on the point of your company, and we're doing the same thing with TPUs, is we're the next incremental evolution to get closer to that picowatt per inference.
Yeah.
Right. And Helen, are you seeing a demand for these kinds of new chip architectures, people wanting to use TPUs in the cloud, people demanding that the chip makers kind of advance the state of the art here when you're talking to businesses? Or are they mostly interested in saying, well, what can I just do today on standard hardware? I'm not so interested in these very edge case, massive use cases where we're going to need a better chip.
Yeah, I think it's a real dispersion. So as I've already alluded to, I think there's a huge amount that can be done just to absorb today's technologies without getting into new architecture. But the point you raise about the carbon footprint and the climate impact is coming up really fast behind us. And so in that sense, I think it's about to go right up the agenda of a lot of businesses that we haven't seen so far think about it.
Right. One of the things we've seen is that a number of countries have started to view AI as a strategic asset. China has made a big case of making AI a national strategic priority. The U.S. has started to, maybe partly in response, to think the same way. And there's been some discussion in the context of, we've seen what's happened with Huawei. We've seen what's happening with this sort of trade war between the U.S. and China. There's been some discussion about whether the U.S. should impose some kind of export controls on artificial intelligence technology. Now, these ideas are not really very specific yet. We don't know what exactly. Are we talking about hardware? Are we talking about algorithms? But Nigel, how big a problem is that for Graphcore if the U.S. decides to impose export controls?
Well, I guess we're a British company, so whether we're subjected to American export restrictions is unclear, I guess is the first question. I think generally, though, you've got to be quite careful here. We don't want to create a war on AI. You know, we don't want to create two camps. You know, I think the research community has advanced very, very quickly because they've shared, you know, this idea that archive is this resource where people are uploading research papers. They're not peer reviewed, they're actually reviewed by the group, and it's more the importance of the paper becomes the powerful thing. And I think if we were to move away from that, the risk is that either overall the technology would slow down or perhaps more dangerously, one side would get ahead versus the other. And you don't know which side would win on that. And that would be a bad outcome for all, I think.
All right. Scott, Google, how concerned is Google on this?
Well, if you look at where we're investing and what we believe in is that the smartest people in the world don't work, they're not all at Google. They're out with all of us here. And that's where the highest concentration of smart people are. So what we're doing is we believe in taking these algorithms and publishing them as open source, publish them in peer-reviewed research to advance the state of the art. And that's where we see is, we believe in open source, and the community will solve these problems. And we have, case studies, for example, the internet was, again, initially funded by government, but that evolved through an open source approach. And so that's what we're doing with TensorFlow, with Kubeflow, and with these techniques, is keep it as science. Now, science, of course, as it advances, governments will think about, those scientific developments. What does that mean for national security? And I think governments will have to make their own decisions about that. And the nearest thing I can think of, Nigel, was thinking about cryptography and how different governments treat that differently. But in general, mathematics, that does a lot of good for our own privacy. And so we're more about investing in the research and advancing state of the art.
Yeah. I met...
Helen wants to get in, I think.
Oh, no, I was going to say, I do think there is an interesting conversation to be had in the space of technology and AI about what China's doing and what the US is doing versus what we're doing in Europe. Because, we don't come close in terms of scale, either in terms of development of technology or in terms of diffusion of technology, any independent country in Europe. So I do think there is a question about what do we do together to perhaps create a third way, and maybe that's around the ethics we use, the laws we use. I'm not sure, but I do think there is a big conversation to be had about how do we carve out our space, albeit kind of continue to foster the international communities, which I think all of our organizations are part of.
Right.
I was just going to make the comment, last night I met the world's first minister for AI from the United Arab Emirates, and he pointed out that, before we had electricity, we didn't have ministers of energy. Before we had telecoms, we didn't have, ministries for communications. And so it's natural that as these new technologies emerge, there will be governmental regulation that applies around them.
Right. Helen, I wanted to ask, you're talking a lot of businesses that are trying to start using AI. What are some of the use cases that really excite you? What do you think some of the best use cases that are out there right now today are for this technology?
It's a great question, and again, it's so diverse, it's almost hard to land on any one. But the use cases I like the most are where you really see this interplay of machine and human come together. And I guess I'll just give one example. We're working for a pharmaceutical company recently, and they're having to look at, when you have instances in drugs that aren't necessarily predicted, like how do you categorize those? So there are 70,000 ways you might categorize them, and at the moment it takes humans 3 days to process 1,000 instances. So do you, have a headache when you're meant to be sorting out something to do your toe? And we built, the accuracy level is actually pretty high, it's 90%. We built models, bought 4 models, and it increased the speed enormously. So what was done in 3 days can now be done in an hour, but the accuracy drops a little bit. But actually, when you bring them together, so you give the humans 3 potential examples, and they then categorize, you can do something in an hour and 5 minutes that used to be done in 3 days. And for me, that's kind of a very simple example, but it's bringing together the technology and the human that I think for me is the most exciting about being in this area.
That's interesting. I think, Nigel, when we were speaking before, you also thought some of these uses in science where you kind of bring the human in, but in that sort of field are some things that excite you. Maybe you can talk a little bit about that.
There are so many problems that we can't find a precise answer to. There are so many problems that would take too much much compute to actually come up with a precise answer. Is mathematically, we call it NPhard problems. You know, so you take something like protein folding, where you want to fold a protein so it will match to a specific disease, and then you can attach a drug to that protein and deliver the drug exactly, say, to the cancer tumor, and it will align on the delivery path so that the drug only attacks the cancer and doesn't attack anything else inside the human. You know, solving problems like that, you know, because cancer isn't one thing, it's many different things. You know, solving problems like that will only be possible with AI, and it will be people working with AI to discover what's the next experiment we should be doing, learn from that, use AI to then work out what the next experiment after that is, until we finally get to a solution that really works.
How about Scott? What are you seeing that most excites you that's going on right now today?
Two areas. I think one we talked about in science in general. This new technique that we've developed as a human race is a universal predictor, and it's becoming almost a universal creator as well. And when it predicts what's happening in science, you can do things like you talk about protein folding, quantum chemistry. It's actually 5 to 6 orders of magnitude faster than humans and scientists, and often more accurate. That's powerful. The second area is where, from economics, where do we have a dearth of humans? There's this labor participation rate that's just plummeting, and where the aging population, there are more people who are relying on society now. And then how do you have humans serve them? So simple things like calling up and getting in contact with a company. No one likes waiting. Yeah. And so can you shorten the cycle time to actually resolve your issues as a government? There's like so many documents to read. We don't have enough people to hire to read them. And so can you use AI for that? Or the same thing for medicine. We have so many more people who are going to depend on medicine. There aren't enough doctors. Mm-hmm. And so those are the kind of areas where AI, we think about, people ask about taking jobs away. We need AI because there's labor shortage to serve that population that needs help.
All right. When you talk to businesses about why they're deploying this technology, Helen, are you seeing is it mostly to enhance revenue, or is it to drive down labor costs, essentially? When you talk to business leaders, why are they so interested in this?
So I think it's both, and I think it's important to recognize that if we only look at AI for efficiency purposes, we're going to miss out on the huge opportunity. In this country alone, if you look out for the next 10 years, there's the possibility to boost GDP by about 20% using these technologies. But if we're efficiency focused, we're never going to get there. So I think it's about looking across the value chain, because that's the only point at which you manage to truly reimagine business models to get to that level of innovative growth, rather than focusing on cost-cutting point solutions that is a little bit of a race to the bottom.
Scott, are you seeing the same thing?
The short answer is yes. Yeah. I mean, I think it's, cost setting, that's one of the first things they may look at, but a lot of it is these techniques are far better at understanding what your customer may want next, or how to improve your process than we are. And that's what we found interesting at Google. Is just a few years ago, we looked at our core business, and we asked the question, what if we could use these techniques to model customers, to model our processes? And initially, we didn't trust it, and it took us a while to get, to adapt to it, but now it's the core of the Google experience. And because it's far better, it gives a much better user experience than we could have before.
Yeah, creates these kind of flywheel effects.
Right.
But I also think there's an opportunity here for AI to empower many more people. So if you think about automation, the idea that you're in a small town somewhere and you can use automation to turn your creative idea into a product, and just like the internet sort of levels small companies against big companies in some cases, I think the same can happen with automation as well.
Right. I want to ask a quick polling question on what is holding back the deployment of this technology right now in a lot of businesses. Is it lack of data? Is it lack of expertise? Is it lack of transparency? Or is it ethical concerns? I don't know if you could put the poll up, but I'd be curious what people think out there on that. And maybe, Helen, what are you seeing when you talk to businesses and they're sort of afraid of using this, or they think they can't use AI? Why? What explanation are they giving for that?
Yeah, I mean, so I think it's much less that people are afraid of it, although in some instances, obviously, there is ethical concerns. But I think it's actually much more about a kind of capability and cultural aspect. I rarely see technology as like the initial blocker in terms of diffusing AI, but there's actually a huge mindset change that has to go on. I mean, you can create, as you're saying, a great next product to buy model, but if fundamentally your workforce and your salespeople don't believe in it, then its impact is going to be very low. You know, you can create great networking models about how to optimize pumps in oil fields, but if the workers don't want to implement it, then again, the impact's zero. So I think there's a big organizational and mindset kind of feature that is actually, which kind of links to, I guess, lack of expertise, but I would explain it a bit more broadly than expertise to be cultural too, is the main, the challenge that we most regularly see.
Great. What sort of myths are there out there about what AI, you know, what can't it do today that people sort of think it can? And when you talk to businesses, Helen, what are they telling you? And you have to say, actually, no, you can't do that, or that's not actually a good use of this technology right now.
I think there is, you know, it's well documented that there is a huge amount of kind of social, emotional, problem-solving skill sets that humans are still ultimately the purveyor of. So there's interesting experimentation about putting bots on boards to kind of create strategy, but I think we're a long way away from that kind of holistic, general intelligence. You know, at the moment, we have to be quite specific in what we're asking and demanding of the technologies, but I don't know if you guys have.
Scott, what about you guys? Is there stuff that, you know, you've wanted to do at Google that you found actually you can't do given the current level of technology?
Well, I think that drives a lot of people here in a DeepMind team is, you know, pursuit of general intelligence. We're doing a lot from learning and predicting or sort of nailing that in imagery and text and whatnot. But now what about emotion? What about creativity? What about memory? How does that all work? And we're looking inside the human brain to get inspired by that. And I think where we see you know, companies getting more and more sophisticated very quickly. I've seen a dramatic change just in the last 12 months of talking to CEOs. But where we find it falls short is where they can't frame a problem, either a prediction or a creation, with data. And if you can't frame the problem as a prediction, chances are today it's an ineffective application of AI. It sounds like more of what you might see in a movie.
Yeah. I want to get one question at least in from the audience here. There are a lot of questions. I'm going to try to wrap them together around kind of governance of AI. How do we prevent this technology as it develops from doing things we don't want it to do, from bad outcomes? Nigel, what's your view on this? Are we going to need government regulation here? How is this going to work?
Well, I think if you think about how AI works, we have this knowledge model that we've learned. We're then trying to create some outcomes from that knowledge model that we've learned. So first of all, did we use all the right data to train the model with, or did we somehow build some bias into the model which we need to worry about? So it's really that sort of policy engine on the back end that we need to start thinking about. And the policy engine can't necessarily be people. You know, we can't have, you know, people looking at every Google search and, you know, what the Google search has come up with and whether that's right or wrong. It has to be an engine that does that, and it needs to be trained with AI. And I think this is a new area of research that people are working on. And I think it's important that we get that right now, because as the AI becomes more powerful, if we can control the policy engines which control the outcomes, then we'll be in a much better position to actually control what these systems do.
Scott, I mean, what's your view on this? Because you work for Google, it's a big company. Again, there's a lot of questions here around, you know, this technology tends to kind of concentrate power in the hands of companies that are already very large, already have access to large amounts of data. Again, how do we make sure that the companies that have this are using it for good purposes?
You know, I think we took an initial take at it, you know, and think about AI ethics and AI privacy. You know, we take privacy very seriously. You know, we're literally one click away from another search engine. And so it's very hard to get at any user data at all inside Google. And so if you think about the data for here, how do you respect the ethics and privacy? And ethics are a function of time and location as well. And we're finding now, people say, well, how do I use an AI if I don't understand how it works? Well, we do that all day long. In the sense that we work with people, we don't know what's firing in your head, but we can ask you, where'd you get your data? What logic did you follow? How were you trained? And what are the governors around that human being in the loop in business? And now take those same things now with a machine that's now going to be part of that decision-making process. And so we've done this as businesses, and I think McKinsey and whatnot are consulting on how do you do this really effectively. And now you're doing this now with machines. And they're becoming a new participant in the workforce to take a lot of the drudgery away, and frankly, make our jobs a lot more interesting.
I know one area that people are very concerned about is facial recognition. That's a computer vision technology that's here right now today. Governments are already starting to use it. Businesses are talking about maybe using it. Yeah, but it's very controversial, and we have a number of big tech companies, Microsoft and Amazon, have come out and called, said they want to be regulated. They want to have some kind of laws around this so they kind of know what's allowed and what's not allowed. Scott, Google so far has not come out so explicitly and called for regulation, but what's your view on facial recognition and some of the law? San Francisco just passed a law banning government use of this technology. What's your view on this kind of regulation of that space?
I think it's a very timely question. We're seeing in certain parts of the world where facial recognition is being used in a way that's abhorrent to most of society. And so we look at that and saying, we haven't yet figured out how to use this carefully. And so until we figure out as a society how we can use that carefully and protect privacy, we shouldn't release products until we really think through thoughtfully how you can use this technology. So for that particular reason, we're not releasing techniques that you could use to recognize faces. Right? But you are seeing it, for example, in generating faces and whatnot in different companies. But in terms of facial recognition, there's so many examples today where we know we haven't figured this out yet.
And
what are you
I was going to say, just briefly on the point of regulation, I think it's very the reason it's difficult for regulators to do this at the moment is because it's very difficult to answer these questions in the abstract, and also the space is so fast moving. So what I think that means for us as kind of practitioners or organizations is that it's incumbent upon us to embed our values and our culture into all the tools that we're creating. Right. So whether it's making sure all of our models by design are debiased or by design are explainable, or however we choose to take it. And I think more and more you're seeing practitioners take that upon themselves, and if you create the case law that I think will help regulators in the future.
Nigel, what do you think about this question? And how we talked a little bit off stage about how you might do this. Is there a way to do this mathematically, algorithmically, to try to make sure that you're guarding against some of these dangers?
Yeah, I think it's difficult. There's many gray areas here, right? So on one level, surveillance security keeps us safe. When we do credit card payments on the internet today, AI is actually making sure it's you that is making that payment, that it's not somebody else who's stolen your card. And so we rely on AI to keep us safe. But where's the line where it becomes spooky? Do we trust people with that data? It really becomes the key thing. I think the thing about regulation. Big internet companies, Google, are saying, we need to be regulated, not Google necessarily. But actually, we've got in our own workforces people who can tell us what's right and what's wrong, what seems correct. And so maybe rather than setting up ethics boards and kind of outsourcing the problem to somebody else who's going to tell us what to do, or government's going to regulate us and tell us what to do, and in the meantime we'll just do whatever we want, maybe we should be asking our employees to say, what do we think is right? What should we be doing? What should we be saying yes to? What should we? And you've seen the kind of kickbacks internally in some of these big companies already over some of the contracts and deals that big companies have got engaged in.
Well, that's a great point to end on, that idea of sort of inclusion, and maybe by asking for more input and more voices from all aspects of companies that are helping to develop this technology, we can maybe end up in avoiding some of these pitfalls. We're out of time, but thank you very much for listening, and thanks to my panel. They were great, and I think we have the Chancellor coming up, so stay tuned.